In the vast tapestry of the cosmos, stars live brilliant yet finite lives. They are born in clouds of gas and dust, shine for millions to billions of years, and eventually meet their end in a variety of dramatic ways. Among these, the most powerful and awe-inspiring demise a star can experience is a supernova, a cataclysmic explosion that can outshine entire galaxies for a brief time. Recently, attention has turned toward a particular star, Betelgeuse, a red supergiant located about 642 light-years away in the constellation Orion. This stellar titan, nearing the end of its life, has exhibited unusual dimming events that have sparked global speculation. Could Betelgeuse be on the verge of going supernova? And if it does, what would that mean for Earth? Betelgeuse is no ordinary star. It's enormous, about 1,000 times the radius of our Sun, and if placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and even Mars. Its red hue and pulsating brightness have captivated skywatchers for centuries, but in late 2019 and early 2020, astronomers observed something strange. Betelgeuse began to dim significantly, losing over 60% of its brightness. This unexpected behavior led many to wonder if the star was about to explode. A supernova of Betelgeuse's magnitude would be visible from Earth even during the daytime, shining as brightly as a full moon. It would be a once-in-a-lifetime celestial spectacle, both beautiful and terrifying. While scientists eventually concluded that the dimming was likely due to a massive dust cloud formed from material expelled by the star, the episode served as a stark reminder of the star's unstable nature. Betelgeuse is already in its final evolutionary phase, having exhausted its core hydrogen fuel. It now fuses heavier elements like carbon, neon, and oxygen in shells around a collapsing core. Eventually, this fusion process will reach iron, a dead end for nuclear fusion, leading to core collapse. Within seconds, the core will implode, creating a shockwave that blasts the star's outer layers into space. This explosion, a Type II supernova, would unleash more energy in a few days than our Sun will emit over its entire 10 billion-year lifespan. So what happens if Betelgeuse explodes in our lifetime? First, the light show would be spectacular. The supernova would be visible without a telescope for weeks or even months. It would dominate the night sky, casting shadows and perhaps even disrupting nocturnal animals. Some ancient cultures might have seen similar events and interpreted them as omens. But beyond the visual impact lies a more serious question. Could such an explosion pose a threat to life on Earth? To answer that, we need to understand what a supernova emits. Along with visible light, a supernova releases vast amounts of high-energy radiation, including X-rays and gamma rays. These emissions travel at the speed of light and would reach Earth as soon as the explosion becomes visible. If Betelgeuse were closer, say, within 50 light-years, the consequences could be severe. Gamma-ray bursts from a nearby supernova could strip away Earth's ozone layer, exposing life to harmful ultraviolet radiation from the Sun. This, in turn, could lead to mass extinctions. Fortunately, at 642 light-years away, Betelgeuse is not close enough to pose such a threat. Most scientists agree that while its explosion would be dramatic, it would not harm life on Earth. However, the effects might not be entirely negligible. The influx of cosmic rays and radiation could subtly influence Earth's atmosphere. Studies suggest that increased cosmic radiation from past supernovae may have affected cloud formation and even triggered minor climate changes. More intriguingly, researchers have found deposits of a rare radioactive isotope, iron-60, in deep-sea sediments and lunar samples. Iron-60 does not naturally form on Earth, it is created in supernovae. The presence of this isotope hints that Earth has, in fact, experienced nearby supernova events in the last few million years. These findings suggest that while not apocalyptic, the influence of such explosions on Earth's biosphere might be more significant than we once believed. A future supernova could also have subtle impacts on technology. Modern civilization is highly dependent on satellites, power grids, and communication networks, all of which can be disrupted by high-energy radiation. A sudden burst of X-rays or gamma rays could interfere with satellites and potentially cause damage to sensitive electronics. While Earth's atmosphere offers protection, a sufficiently strong and nearby event could still pose challenges. Astronomers and engineers continue to study these risks to prepare for such eventualities. Interestingly, the warning signs of a supernova can also come from neutrinos, tiny, nearly massless particles that rarely interact with matter. When a star collapses, it emits an enormous burst of neutrinos, far outpacing the light from the explosion. These particles can reach Earth hours before the light does. In fact, neutrino observatories around the world are designed to detect such bursts, serving as an early warning system for nearby supernovae. If Betelgeuse were to go supernova, scientists might first detect a spike in neutrino activity, followed shortly by the brilliant explosion in the sky. Despite the many questions surrounding Betelgeuse, one thing is certain. Its explosion will mark the end of an era for stargazers. The star has been a cornerstone of celestial navigation and mythology for millennia. Ancient cultures saw it as the shoulder of Orion, the mighty hunter. Its disappearance would reshape the constellation and serve as a poignant reminder of the impermanence of the cosmos. What's more, a supernova in our galactic neighborhood would provide scientists with an unprecedented opportunity to study the life cycle of stars in real time. Telescopes around the world and in space would turn their gaze toward the dying star, capturing every moment of its transformation. Instruments like the James Webb Space Telescope could analyze the composition of the ejected material, shedding light on the processes that create heavy elements like gold and uranium, elements that ultimately become part of planets and even people. In this sense, the death of Betelgeuse would not just be an ending, but a cosmic beginning. There's also a cultural dimension to consider. A supernova visible to the naked eye could captivate the public imagination like few other events. Social media would erupt with images and videos. News outlets would cover the phenomenon extensively. Artists, poets, and storytellers would draw inspiration from the glowing beacon in the sky. It would unite humanity, if only briefly, in a shared sense of wonder and curiosity. In a world often divided by conflict and politics, such a celestial event could serve as a rare moment of global reflection. And then there's the philosophical question. What does it mean to witness the death of a star? Light from Betelgeuse takes over 600 years to reach us. If it explodes tonight, it actually happened centuries ago. We are seeing the past unfold in real time, peering into a cosmic memory preserved in starlight. That alone is a humbling thought. It reminds us of our place in the universe, not at the center, but as silent observers of ancient dramas playing out on unimaginable scales. The legacy of Betelgeuse may also extend to future generations. Once it explodes, the remnants will form a supernova remnant, an expanding cloud of gas and dust that can persist for thousands of years. Such remnants, like the famous Crab Nebula, become laboratories for understanding the physics of matter under extreme conditions. They also contribute to the cosmic recycling process, enriching the interstellar medium with elements that can seed new stars and planets. In a very real sense, Betelgeuse's death will help birth new worlds. Astronomers continue to monitor Betelgeuse closely, using every available tool to detect changes in brightness, spectral composition, and surface activity. They have even mapped the star's surface, observing giant convective cells that cause irregular flickering. But predicting exactly when the star will explode remains a challenge. It could happen tomorrow, or 100,000 years from now. Stellar lifespans, though long by human standards, are fleeting in the grand scheme of the universe. For now, Betelgeuse continues to flicker in the night sky, a silent giant nearing its final act. And while its end is inevitable, its story is far from over. Whether it explodes in our lifetime or long after we are gone, its supernova will mark one of the most extraordinary events in astronomical history. It will offer scientists invaluable data, inspire countless individuals, and remind us of the grandeur and fragility of the cosmos. Here at Discovery at 2.0, we invite you to keep your eyes to the sky. One night, perhaps sooner than we expect, that familiar red dot in Orion may suddenly blaze with the light of 1,000 suns, heralding the death of a star, and the beginning of a new cosmic chapter.